Hello and welcome to this very first Sontay webinar. There are some people have joined us online. We extended the timer a little bit. Before I carry on, I just want to hand over to Phil Berry at Sontay to introduce Sontay, who they are, and just let him explain a little bit about the company, what they do, and where we fit in the marketplace. So over to you, Phil.
Thanks, Andy. Much appreciated. I'll pad this out a bit to let a few more people join. I'm Phil Berry. I'm the UK Sales Director, covering Ireland as well for Sontay. Those of you who don't know Sontay, we are the UK's finest peripheral and field device manufacturer. We are working today in conjunction with Andy Camsell. Andy Camsell is in his own right a controls engineer, master systems house engineer, BCIA trainer for us, and failed stand-up comedian. Unfortunately, he doesn't get many gigs for that side of his business, but where he fails in his comedy, he makes up for it in his prowess on system house maintenance. Andy is also available for parties and weddings, but he's probably more suited to the funerals. He's here today in conjunction with Sontay, and he's going to be giving us our first inaugural webinar on AI. Very much looking forward to that. I hope we've got good attendance. I think we've got about 45 people, so a few shout outs for those people who might be joining us: Josh O'Connor, Bob Kelly, Fraser Eady, Paul Friday, and of course all my colleagues at Sontay. So I hope you all enjoy this. Very much looking forward to it in the great professional style that Andy does for us. So without further ado, Andy, first inaugural webinar, over to you, sir.
Thank you very much, Phil. And yeah, please don't think about a career in motivational speaking. I don't think that's. I was feeling good, and now suddenly I don't. But thanks anyway, Phil. Right. Actually, before we get on, I just want to welcome everyone. We've got about 10 people online. This is being recorded, so you can obviously review this afterwards. We've got a couple of polls, so there is a little bit of interaction in this first webinar. Just to expand on what Phil was saying there, this is the very first webinar that we've done with Sontay. I work as an industry professional. I'm a partner in a systems house, so I'm very much involved in the controls industry. Not an expert on AI. I've obviously researched this. I'm as involved in AI in our industry as most people are, but my role is on the control side of it. But AI and its importance in our industry is obviously, it's going to play a key role as we move forward. So we need to sort of look at that moving forwards. We're going to look at an overview of AI significance in modern technology. I'm also going to do a very brief explanation of building automation because there's some people have joined this webinar with, because it's AI, but not necessarily understanding the BEM side of it. It's not a huge amount, but just want to cover what we do. Most people, I feel, probably do, but let's just cover that base anyway. The other thing that I just wanted to sort of say is this: there is an interactive Q&A at the end. There's a chat as well. So if you've got anything that you need, to say, you can pop that in the chat. I've got a lot of screens going on, so I've got the Vimeo window and my production window and stuff going on. So apologies if I'm not looking at you as things going off to the side. If you've got anything you want to put in the chat, please do. There, like I say, there will be a Q&A at the end. And we also have a couple of polls as well. So if you're watching this on a PC, you should, when I open the poll, be able to choose from a couple of answers when we do those polls. So looking at first the building automation. So an overview. What do we mean by a building automation system? Well, when we are looking at BEMS, building energy management systems, we are talking about systems which obviously manage the energy in a building, but manage the control of that building as well. And these have been around for a very long time, since the late 19th century. It was the late 1800s that Warren Johnson, who went on to create the Johnson Controls Company, first invented the thermostat. And the ability to control heat output, as it was then, has migrated to controlling our heating and modulating our cooling in our buildings. And eventually that moved to electronic devices, which then moved to software-based devices. So when we're thinking about BEMS, we're very much thinking about software algorithms which are running on dedicated computers, taking real-world input from temperature, from relative humidity, CO2 concentration, variables like that, and processing that information and then providing output. So if it's too cold, you open a heating valve, that kind of thing. Now, it's obviously a bit more complex than that, but that is in essence what building control has evolved as. However, there's another element to building control in that now that we have software-based systems, everything exists within our system as data. So we ingest that real world data, the environmental data, and we have data points in our BEMS. And so we can process that data, and we have various applications for analytics, so analytical platforms, where we can look at large data sets. The analytical platforms will create visualizations, and then a person can look at that and see trends, what's happening over time. Are we using more energy where we're supposed to, etc. When we are looking at applying AI to that, we are going to be looking at applying the role of the engineer or the person looking at that visualization of the data to an artificial intelligence, and it will review that data and it will create outcomes based on the input. Now, one of the things that's really important to understand about artificial intelligence is that it differs from standard computing algorithms in a number of ways. There's lots of different types of artificial intelligence, but a brilliant analogy that I came across was the idea of identifying fruit. Obviously nothing to do with buildings, but if you have got or you've trained a computer to identify oranges and lemons, then every time you hold up an orange and a lemon, it will identify it correctly. It will see the size, the color, etc., and it will be able to identify an orange and a lemon. If you were to then show the computer a grapefruit and it had never seen one, it wouldn't know what it was. With AI, it's the ability to make assumptions about a new thing based on existing data. So, for example, with that orange and the lemon, let's just say it's in a supermarket. So we are going into a supermarket with our fruit identifier, and it says, yep, that's a lemon, that's an orange, and then you show it a grapefruit. Now, if it knows that it's with the fruit rather than the footballs, then yeah, it's round, but it's definitely not a football, so it's probably a fruit. It can see the pits in the skin, so it can see that it's very similar to an orange and a lemon. So it will identify it as a large citrus fruit. And so it's made all of these assumptions, which for you and I are very straightforward. You see something, you may never have seen a grapefruit before in your life, but you would know that it's a citrus fruit based on those other criteria. And that's what AI is doing. It's looking at other criteria, and the machine learning is discerning what the new thing is based on what it already knows. And that's what makes it intelligent. So AI is slightly different, like I say, from our standard algorithms, where we have very fixed and rigid outcomes from the input that we put in. One of the things that happened, I did this seminar at Smart Buildings back in October 2024. I got talking to some people who know a lot more about AI than I do, is that whilst the machine learning is quite an involved process and uses quite a lot of processing power, once you create a model from that, you can actually put that onto quite a small footprint. And so there's a lot of AI models which can fit into embedded computers. And because of that, we obviously see a role for AI in our BEMS technology, because we have got these small single board computers that's getting all the information in. If we have done some machine learning externally and we have placed that model inside that BEMS controller, then there's every possibility that we can use that model to ascertain information about the building. And as we'll see in some of the examples that we've got in these slides, that has actually happened. At the moment, the adoption of AI in BEMS is minimal. It's not, there's not a huge extensive number of buildings using AI, but they are out there. It has been used already. So to look at building services, the kind of variables that we might need, when we are trying to control a building, we need to have information about the environment because we're controlling that building for people to occupy. So we need to know a number of things. Temperature is a key one. We do a lot of temperature applications or temperature control applications. We also look at air quality, and very specifically for us in the BEMS and building control, we're very interested in the CO2 levels, carbon dioxide levels in a space. The more carbon dioxide you have in a space, then it's a good indication the more people you've got. We breathe in oxygen, we breathe out carbon dioxide. So for a long time now, we've been able to control our ventilation rates based on the fact that, there's higher concentrations of CO2. So we need to increase the ventilation to the space to make sure people are comfortable. We also have other values that we can bring in as well. Now, some of that is to do with environment in terms of things like humidity, but occupancy sensors and light level sensors are really important as well. If it's a really bright day and you've only got a light that switches on and off, then it's going to be on. It's a waste of energy. So knowing what the light levels are, the ambient light levels, mean that we can turn that lighting down. And traditionally, we've done this, through having a set point. This is what we want the light level to be. But the idea with AI, as we'll see moving through this, is that it will assess what is actually comfortable and it will make those adjustments for us. When we're looking at sensors, sensors are the lifeblood. I know this is a Sontay webinar and they make and sell sensors, but it really is the lifeblood of BEMS, and it's going to continue to be that as we move into this new AI era, because AI is a brain. You think about a person. A person is a brain. You are the thoughts, you are the processing of the information, but you need senses. You need to be able to touch things, to see things, to hear things in order to get information in to make those decisions. And so having sensors to accurately sense that information, and I really stress accurately sense that information, is really important. So having sensitive and accurate sensing technology is key to making AI work, because if you've got an AI, it can be as intelligent as you like, but if you're feeding rubbish information into it, you're going to get rubbish information out. It's like, if you have your grapefruit, you're trying to identify it, and you've painted it in all stripy colors. It's rubbish information. It doesn't tell you anything about the grapefruit because it's not correct information. So we need to have good sensing technology to make this work. AI can enhance the capabilities of sensors. Now, whilst it's important to have it's important to have good and accurate sensing information in there. AI can be used to identify patterns. And this is something else about AI, which we need to bear in mind when we're thinking about implementing AI in the built environment, is that the more data you have, the easier it is to see what those trends are, or for the AI to see what those trends are. It can't, if you give it one sensor and tell it that's the temperature, that's all it knows. So if you have a whole bunch of temperatures and anomalies are found, then that is an indication that there is an anomaly. Something is wrong there. It could be the sensor is inaccurate. It could be that there's a different occupancy pattern. Something else is happening in that building or in that space within the building. But the more data we get, the more accurate those algorithms can be. So it can enhance the capabilities of our sensors. In terms of AI, one of the most sort of common uses, and like I say, we'll see this in these two case studies that are coming up, is the idea of energy optimization. Of course, it's a use of AI that people are going to want to exploit, because if you are if you're using too much energy, you're paying too much money. You want to reduce your costs. So it's a huge driver. So one of the things that we look for to AI, and certainly we have done for manual analytics for some time, is to identify trends where we're using too much energy in spaces where we shouldn't be, and to reduce that energy consumption. Now, of course, one of the benefits of using AI rather than a manual process for that is that AI can make that assessment and make that adjustment for you without any interaction. Whilst as a BEMS engineer, that's fairly scary. The notion that you could do that as a building owner, then that obviously enhances your capabilities, enhances your energy optimization by automating that process. As we already mentioned, lighting control is another key element here. If we can look at ambient light levels, we can see, or the AI can change light levels, artificial light levels, to match what is required for that time of day. And you can bring more information into that as well. If you look at occupancy levels, if you've got, nobody in a room, then you turn the lights off. That's a fairly simple and straightforward algorithm. Yes, room's occupied, room's not occupied. But with an AI, you can set that algorithm in place to look at your building, and it will learn where spaces are occupied, where they're not occupied, can set light levels, heating levels, etc., based on that. And certainly that has been the case with the Edge in Amsterdam, which is one of the big AI buildings that we've seen implemented over recent years. Security and access control can also feed into that AI model. If you know who is in a space, then it's all a little bit Big Brother, admittedly, but the AI can get to know what those personal preferences are. Now, they have to be within reasonable parameters. You can't say, this is Mr. Smith's in today. He likes it at 32 degrees C in there because he likes to sit in his swimming trunks. It needs to be within reasonable parameters, but you can get individual adaptations as people move around a building. That can lead to, obviously, energy efficiency, definitely improved comfort for building occupants and well-being, but it can also assist with maintenance tasks as well. Predictive maintenance. If we start thinking about predictive maintenance, again, something that's been around for quite some time, we look at vibrations of plant, and we see that when they're starting to fail, when bearings might be failing, and so it needs a maintenance. But AI can assess that and provide maintenance regimes when the plant is requiring maintenance, rather than just looking at these fixed thresholds. It's like, it probably needs a maintenance. It can bring all the data in and create a predictive maintenance regime. So instead of having a daily worksheet that is printed out based on a time frame, so you've got your FM package and it prints out, these are your assets, these are when they need to be looked at. It can actually look at that. So yeah, it needs to be looked at after 3 months, but this pump hasn't run for for 2 of those 3 months, and we're not seeing any problems. We can probably knock that on to for another 2 months. So it will learn what the best maintenance regime is for the assets that you've got within your building. So AI can provide a huge amount of input and drive that process. Again, ultimately reducing costs. In terms of the case studies, there are very few buildings which are actually using AI to its fullest extent at the moment, but there's certainly some implementations of buildings which use AI, and the results are already astounding. Now, the poster child of AI buildings is the Edge in Amsterdam. It's, I believe, it's the first carbon negative building, so it creates more energy than it uses, but it's very well known about, and a very successful building. And part of that is obviously down to the people who designed it. It's down to the implementation of the technology that goes in there, but it has AI driven features, and the AI is what has driven it to become incredibly energy optimized. So in terms of energy consumption, it looks at how much energy is being used in the building and how energy can be saved automatically. And this is one of the things with AI. We've been doing this in our industry for a long time, but it's people like me who go out, yeah, I think if we tweak that and tweak that, then we can reduce energy consumption without having any significant impact on occupant comfort. Now we've got AI doing that. So AI can look and make those adjustments. This energy consumption could be reduced, energy optimization could be improved without any significant impact to what's going on in the building. We can also look at personalized workspaces, which has happened here. So there is a smartphone app for when you're in the Edge in Amsterdam. And based on your requirements, you can make adjustments. It will learn what your preferences are. So you start off, you're booking a space. So you use a smartphone app to find the space, and then you set your preferences in that space. Eventually the AI learns that as you book a space, it's like, there we go. These are your preferences for this space. Now, it's not, some ridiculous dark magic where you can have a big open plan office and everyone sitting at an individual desk can have a different temperature. That doesn't work. You can change the laws of physics, as they say. But if you've got individual offices and each one is served by a set of environmental controls, then you just need to book that space out and it will be adapted to your personal preferences. By doing that, although you don't particularly see that at the front of it, it just looks like some prima donna wanting exactly the right temperature. But it's honing that system specifically to your requirements. When you're not in there, it's not. That's really where the key savings come in, because when you are done with that space, you've moved out of that space, whatever, it will revert to its previous settings, its unoccupied state, or it will start getting ready for the next occupant who may have slightly different requirements. But it can go beyond that as well, because what it can do is it can see the similarities between two consecutive occupants. It's say, all right, well, if I took that one up a little bit and that one down a little bit, then we wouldn't actually need to make any changes at all. And I don't think these people would notice. I say think, that's in inverted commas, but that is how it will adapt the algorithms to suit. The Edge is, like I say, it's one of the most energy efficient buildings in the world. It achieved a BREEAM rating. BREEAM is the Building Research Establishment Energy Assessment Method rating of 98.4%. It's one of the highest ever awarded. It is it's, I mean, that's incredibly high. You just don't get buildings that do that. We're always building better buildings, but to get 98.4% BREEAM rating is incredibly high. In North America, thankfully in Canada, we still love Canada, they have a slightly different approach. They use LEED as their assessment method, and one of the LEED Platinum buildings is Cisco's Toronto office. Now, Cisco's Toronto office is, it's a standard office block, but obviously Cisco, a technology company, they wanted to use AI to drive their processes. Again, smart HVAC and lighting systems adapted to as people move through the building. And they also introduced air quality monitoring as well, so that as you move around the space, air quality is correct for where people are. Now, obviously, I don't know what the working profiles are for Cisco, their Toronto office, but if you've got large groups of people moving around a building into meeting rooms, for example, and then out into open plan offices, you want to make sure that the ventilation is matched to those spaces. It's not impossible to count people in a space, but it is quite a tricky thing to do, which is why we use CO2 as our metric. But by using people counters and moving, and watching people as they move around the building, feeding that into an AI model, they can actually adjust the ventilation rates based on as people migrate around the building. So it's created a really comfortable place to work. Now, the benefit of AI here, of course, is that reduction in energy consumption. That was no doubt the goal to start with. Everybody wants to reduce their energy costs. But it is also about the efficiency of the workers within that space. If you're in a comfortable environment, you work more efficiently. Yeah, it's been some recent experiments have been done about cold, people working in the cold. And you would think, on a nice sunny day, 18 degrees C is quite warm. But when you're sitting at a desk in a house or in an office, that's 18 degrees C is quite chilly. And so your productivity drops off when you get a little bit preoccupied. Your brain slows down as well. There's all kinds of other things going on. But by creating an office environment which is as comfortable as possible. Yes, it improves well-being, but it also improves the efficiency of the comforts of the company. Sorry. So not only do you get the energy efficiency, but you also get the benefits of having a workforce which are, obviously. Working more efficiently within that space, and so you get greater productivity from your team as a result. So those are two buildings that we've got at the moment. Where does that take us in the future? Well, the predicted advancements in AI sensing technology over the next decade, and they are predictions. It could be that none of this happens, but looking at the trajectory, it would certainly suggest that the enhancements for AI, the algorithms are becoming more intelligent, for want of a better description, but also the models being able to put on smaller and smaller platforms. We can see that the predictive capabilities of AI are only going to become more accurate. And so we can deploy AI to create more and more smart buildings. The impact on energy management and user experience is starting to be seen already, and there's a lot of people who are looking into particularly the energy side of it, because energy is quantifiable. If you look at energy management, if you deploy AI and you reduce your energy costs, it's very easy to quantify the ROI, the return on investment for deploying AI. With a user experience, it's less so. It's more ethereal. If people are happier in the space, their productivity is going up, maybe that leads to more profit, but it's less quantifiable than a straightforward, we've deployed AI, we've saved X amount of pounds as a result. But certainly those things, energy management and user experience, user comfort, are going to be improved as we deploy more AI. The other thing that we sort of see, the other trend, is what is described here as emerging technologies. I mean, they are kind of emerged now, but they are technologies which are still being developed and rolled out. IoT, LoRaWAN, and 5G being three key examples of this. IoT is one of my pet hates. I hate the Internet of Things. It's like a load of IT bods went up the pub and said, "Oh, we've got this. What are we going to call it? I don't know, the Internet of Things." Another drink. It's just seems like a lazy acronym, but it perfectly describes what is happening. The Internet of Things is device to device communication, so machine to machine communication across the internet. Traditionally, the internet has been about humans interfacing with machines. You sit at a terminal and you interact with the internet. Now, devices can communicate with each other. So this Internet of Things idea very much feeds into the ability to share information and for AI to work. LoRaWAN as well. Now, LoRaWAN is really starting to take off in our industry. It stands for Long Range Wide Area Networks. It's a sensor network which was originally developed for the cold chain, so for moving food around and monitoring cold processes, so refrigerated transport as it moves around, to reduce the costs associated with using 3G and 4G signals. But because the sensing technology works over such a long range, it actually has I say recently, of sort of within the last 5 years, emerged as a really useful technology to be able to deploy within buildings so that you can put sensors in lots of different places in your building without introducing any new wiring. Now, of course, there are enormous benefits to that. And I think actually the next webinar we've got planned is on LoRaWAN. But if you want to add a whole bunch of sensors, because you need to feed information into an AI model, then of course having that, being able to do that without wiring everything up, is enormously important. LoRaWAN is also an IoT technology because it can feed directly into the internet and be decoded online. But LoRaWAN itself is this radio sensing technology. And of course, the deployment of 5G is going to be very important as well. 5G rollout, if it happens as it should do, is going to be a significant change in the way that we utilize mobile communications. Yeah, we've had mobile phones for a long time now, mobile networks for a long time. And it's really when 3G came along and people started using data, and then we realized we needed 4G, and now 5G is realistically the first usable iteration of those data networks where we can get very high bandwidth, fast communications, and we can get that in remote places. Thought is being given as to how to get that in remote places. Now, I know if some of you have got 5G phones and you've been in the countryside, you're probably thinking that's rubbish, particularly if you're on O2. But that is the idea behind 5G, is to have these completely wireless networks based on these GSM signals. And if we can share information over those long distances, we can share information wirelessly, we can feed that into AI models. So the combination of this idea of IoT, and then under that umbrella, the LoRaWAN technology and the 5G feeding information into AI models, we can get much better management of our buildings as a result. And that's all buildings. It doesn't need to be in a metropolitan area or a huge building. It could be a small domestic dwelling in the middle of nowhere, and using these technologies together, AI can enhance that. And I'm sure we're seeing some of that already with home smart technologies, things like the Amazon products. Google and Apple have their similar products. I don't want to say her name because she'll go off in the corner. Challenges to AI. So there's a lot of challenges to AI. So one of the challenges for AI is integrating AI with existing technology. There's an element of there's an element of training which needs to go on. So you need to upskill a workforce to be able to do this. We also need to think about interoperability between systems. Now, that happens a lot these days without people even needing to think about it. A lot of technology platforms, you look at the Schneider AS product. So I do a lot of work with Johnson Controls EasyIO. These are platforms which are designed specifically to integrate with IT. So as you bring your sensor technology into it, then it is just bringing that data into essentially what is an IoT form. Yes, you have to do a little bit of programming in there to get that to happen. But these are platforms that are designed to integrate with IoT. Yeah, others are doing the same, as those are just the ones I'm most familiar with. So a lot of this is happening inherently now. But if you've got legacy product, you need to think about how you are going to integrate those sensor networks into your AI model. Now, that technical challenge doesn't necessarily need to be as difficult as you might think. There are a lot of products which will ingest standard sensor data, so sensors that have been around for a while now. You can ingest that information and you can make that available as data for AI applications, for sending up to the cloud, whatever you want to do. So it's not beyond reason that we can adapt to that, but it is a technical challenge to integrate those legacy systems. We also have ethical and privacy considerations. When I did this seminar, one of the questions I got was, do you think that AI could be used for nefarious means? Well, the short answer to that is absolutely 100% yes. it would, you'd have to give some thought as to how that might happen within the built environment. But of course, we've already seen AI being used for some quite unethical reasons. And so we also need to think about what the landscape might look like in terms of legislation as we move forward with AI. It can't be allowed to just run amok. At some point, someone says, right, you're allowed to use AI to do this, you can't use it to do this. Or there are, let's say, privacy considerations, ethical considerations. Tracking of people from building to building could become very easy and very possible. And that has, like I say, huge ethical implications. So we have to overcome those challenges. I would expect to see a point before not too long, quite in the near future, where this becomes a really robust discussion, political discussion, and maybe hard barriers are put in place. Whether that will affect what we do with AI is difficult to say, but I can see them coming. And of course, cost and scalability issues are something which we need to consider. One of the interesting things about AI is that it actually right now uses a lot of energy to drive the machine learning. Now, again, that's been in the news quite recently, where there's a new model or a new system in China which doesn't use quite as much energy. But don't want to get all bogged down in that discussion too much. But traditionally, AI is using a lot of energy to do the machine learning. The weird thing, of course, with that is we are using a high energy consuming system to create energy efficiencies elsewhere. Now, there comes a point when you've done the machine learning and you've got the models, and so it is a finite amount of processing, but there is a juxtaposition there which needs to be considered. So there's a cost to it. There are also scalability issues. We need to drive these systems to be completely scalable. And at the moment, using AI comes with a cost because there are scaling, I wouldn't say scaling issues with it, but the cost of upscaling the AI, the machine learning, is high. And so you have to pay quite a lot for it. As that cost starts to come down, the scalability issues will likely be addressed as well. But again, it all feeds back into the whole discussion, the ethical discussion. Should we be building, data centers or giving over huge areas of data centers to AI modeling, just because we want this processing power? If we're building all these data centers to process data, what place do humans have in there? We have an interesting problem here, in that we're creating AI to make buildings more comfortable for people, that people aren't needed to work in these buildings. So there's lots in the mix and lots of challenges and considerations, and they're not all technical ones. There is huge ethical considerations and privacy considerations around AI. So I just want to recap the key points there, just to say that looking at the transformative technology of AI, we are going to see changes within the industry as time goes on. What's going to be interesting is seeing how long that takes. And of course, we have to think about the future of AI and where it is leading us in terms of the technical considerations, the ethical considerations, and how that will impact the wider built environment, the people's requirements to actually use buildings. There's a couple of questions here, so I've got a poll now. Just want some thoughts, because when I've done this seminar before, I've generally been speaking to BEMS engineers, and I know there's a real mix in here. So just like to get your thoughts on this. So if you can see that on the screen, it should say AI won't have any significant impact on the BEMS industry for at least 5 years. So if you could agree or disagree with that, I'll just give you a couple of moments to sort of have a look at that. So far, I'm seeing 66-33 disagree and agree. So if you are agreeing with that statement, you're agreeing that AI won't have a significant impact on the BIMS industry for at least 5 years. 50-50. Oh, we're not seeing a lot of impact on this. Okay, that's interesting. Be interested to know what some of you guys do out there. So I'm just going to move on to the second question now. And the second question is is the same as the first question, but because I've done the slide wrong. So there's the first one. So the next question is, aside from, it's not the question on the screen, I'm afraid, aside from large scale analytics, AI will likely only ever have minimal impact on the BIMS industry. So the first question was about what's happening in the next 5 years, and this question is about the longer term future. So aside from large scale analytics, AI will likely only ever have minimal impact on the BIMS industry. So won't be affecting schools, little boiler rooms in old people's homes, things like that. Okay. Got some different answers there, which is quite interesting. So we've got some results here. So I'm going to just archive these polls and just look at them. So the first question was, AI won't have any significant impact on the BIMS industry for at least 5 years. 66% people think that is the case, and 33% of people disagree. When I asked the second question, aside from the large-scale analytics, AI will likely only ever have a minimal impact on the BIMS industry. 44% of people think that is correct, and 55% of people disagree, which is quite interesting. So this originally, like I say, I did this at Smart Buildings. I'm sure some of you will have spotted this already, but the pictures looked a little bit weird in this presentation. And the reason for that is that this entire presentation, including the images and notes, was created using ChatGPT. And what I did was I typed into ChatGPT, create a PowerPoint presentation about the potential impact of AI on building automation over the next decade with a particular focus on sensing technology. Now, I asked some follow-up questions for examples, but everything you have just seen, I didn't write a word of it. I know it seems lazy, but everything there was generated by artificial intelligence. All of the notes, all of the slides, absolutely everything. So the idea is that to sort of just bring home that we are already seeing an impact. I know this is a PowerPoint presentation, but that was completely created from scratch with a single instruction. And so we need to be mindful of how that could be applied elsewhere. If any of you are BIMS engineers and you use ChatGPT, then just sketch out, not real software, but just sketch out a drawing showing a representation of a sensor and a set point adjuster going into a loop and then attached to a valve in some random way, a coding that you've made up that's vaguely recognizable. And feed it into ChatGPT, and it will almost certainly be able to assess what the intention is. Even though you made it up, it will be able to assess that. Now, that's from a hand-drawn sketch. You can pop that into ChatGPT. It's not a great leap to see that we can, actually get ChatGPT to write code for us, and indeed we do. ChatGPT will already write things like web code, stuff like that. It understands these languages. So it understands JavaScript, you can write Python, all kinds of different languages, just by giving it some just by giving it some simple instructions. It is already having that impact. I created a really small website. We manage a load of remote sites, and traditionally what I would have had to have done was code it all up and get all of these bits and links in there. And I just gave ChatGPT some instructions. It created PHP scripts and JavaScript for me. Now, these are well-known language and well-used languages with a lot of scope outside of BIMS. But how long before we can just say, I want this to write my Tritium application, or my Sedona application, my Schneider application. You just give it a set of instructions and then it does it. And then the next step on from that is, of course, that's embedded into the controllers. I want a pump changeover strategy, and it appears based on the criteria of what you've defined as the inputs and outputs. So it is already having a huge impact. It's developing very quickly. The capabilities for analytics and code are already there. It's well and truly there, and I am as guilty as many people who've worked in traditionally sort of hands-on environment where you've for me, you go out, you do work with screwdrivers and stuff. And so you tend to think that you are shielded from this. But there are two things to that. First thing is the software aspect, which we already talked about. But the other thing is if people need fewer buildings, then there's less work for us. So we do have to consider the impact that it will have on us. But there are positives as well. As with anything, survival is about adaptation. And for building automation, AI is wholly reliant on data input. If we can give it great data to work with, then the outcomes we get will be improved. And so our focus needs to be on how we provide that useful information by using better sensors, by using Sontay sensors. Oh, that's slipped out there. But of course, by using really good, accurate sensing data and a lot of it as well, the more data you have in a building. Now, in terms of projects, anyone here who's working in BEMS and working within the project side of it, when you're doing a project, there are two things which override everything: on time, on budget. And so it's a race to the bottom to get everything as cheap as you possibly can. And so you will put in the fewest sensors you can possibly get away with. So we have to look at this from the ground up and think about specifications which are looking at the overall outcomes for energy reduction. Everyone's talking about net zero at the moment. Net zero is a really it's a really noble goal, but it's a difficult road. To get to that is really tricky. And something as innocuous as a sensor at the bottom of it seems like it's not playing a part in this huge problem that we have. But of course, it is the fundamental building block for starting to look at how we address those big problems. The more information you have from a building, the better that we as engineers, but also AI, can deal with that information, and the lower energy consumption we can get from that building, the greater the carbon reduction we can get from that, and helping us towards this goal of net zero. So using what we do already and improving on what we do and making sure that we have got all of the information that we need from a building is going to be the real key part of of driving building automation forwards in the future, as I see it. So we now have an opportunity for Q&A. We actually do have a Q&A session there. So I don't know if anyone has any questions. I'm not sure who's actually on. I know there are people, but I don't know who's on there. But if anyone does have any questions, I'd be happy to discuss those. It's not a very interactive forum. I appreciate that. It's not like a Zoom call where everyone gets a turn. Looking at that, there don't seem to be any questions there. Okay. What I will do, I'll just leave that open for a few moments to just say this is the first webinar we've done. We don't know whether people are going to want this moving forward. I really hope they do. But if you've got any suggestions at all for what you would like to see from a Sontay webinar, if it's on Sontay products, whatever, then please get in touch with Sontay, because this can be really useful. It's recorded, so it'll be out there. I've got a question there from Lee. What considerations have you given to the potential threats around cybersecurity? I was asked this question in smart buildings as well, actually. So, cybersecurity is a real issue for our industry. In the context of AI, there are significant new issues that we have to think about, because AI can be set the task of looking for holes in security. So yeah, there's definitely issues that need to be thought about there. It's a much bigger question than AI, though, the cybersecurity side of it, because on the cybersecurity side, we need to start thinking about what we do very seriously in our industry. I don't know what your role is within the industry, Lee, but for me, the number of times I go to site and I find, just default passwords all over the place, or simple passwords, or routers with holes in them all over the place, it is huge because people see BEMS as it's only BEMS, it's not that important. So we as an industry need to address cybersecurity definitely. Um, in terms of AI, I think that threat is going to be enhanced as a result, and that's why we need to think about it very seriously. But I don't think I don't think the two things are connected, other than it's going to be more of a problem moving forward with AI than we currently have at the moment. Hopefully that sort of answers the question of my thoughts on it. There's obviously a big discussion there. Okay, no other questions there. Let's come through. Cool. Right, like I say, if there's anything you want to see from a webinar, then please do get in contact with Sontay. We're sort of looking as well. I know 10 o'clock on a Tuesday is not a great time to have a webinar. Most people are at work and stuff. But maybe we could do it later in the evening, whatever, if people really wanted to get involved. Maybe think about a different platform if you wanted to have a bit more of a discussion or whatever. There's scope here. We want to make sure that we're serving the industry, giving the industry what it needs. So on that note, if nobody has any other questions, I'm going to shut down the Q&A session. I hope no one's typing a question, because it's going to seem really rude now. And thank you for your attention. It's been really good to be able to present this. If you have any comments or anything about this, I'm sure there will be a LinkedIn post. Then please carry on the discussion there. It is a discussion. This is how it is. This is a discussion. We're all part of the industry. We all need to get involved. Thank you very much. See you all soon.